Okay, here is our first tutorial for double displacement reactions. We are doing question number 5a from page 103 of the text, and we have ourselves a double displacement question here, and we've also set ourselves up with some molar calculations. It's turning into a limiting reagent problem. So the first step in solving this is to determine what our products in this reaction are going to be. And so to figure that out, we need to take a look at our metals, and we have calcium and sodium, and in a double displacement reaction, these guys swap out. So they will change their combinations. So our calcium will go with the sulfate, and our sodium will go with the chloride. And we will get the resultant products from this reaction. So we will get sodium chloride, table salt, and we will get calcium sulfate. Now we're not quite done yet. We need to take it one step further and balance this reaction. So we notice we always check our metals first, one calcium on one side, one on the other. We have two sodiums here and only one on the product side. So we will need to put a 2 there, and we notice that that now balances out our chlorine on both sides, and we have the same number of sulfate ions on both sides. So we're good to go now. So the next step is, in the question, I stated that we have a mass of 100 kilograms for both our reactants. And what we need to do is to determine, using that information, which one of these reactants is our limiting reagent, and then use that information to determine the masses of our products over on our right side. So first step, I've given you that we have mass in kilograms. And of course, when we go to do these questions, we need to convert kilograms to grams. 100 kilograms would be 100,000 grams, but we don't like using big numbers like that, so we'll switch it to scientific notation. So 100,000 would be 1 times 10 to the 5 grams, and that's the same in this case as well. There we go. Our next step now is to figure out moles. We need to remember that in order to do these questions, if I want to figure out the amount of product I create, I need to remember that these chemical reactions, these equations here we see, work in terms of ratios of products and reactants. So we can't use mass because the ratios don't work with mass. We have to use number of particles, and moles help us do that. And we need to remember our basic formula. So a number of moles is equal to the mass of your substance divided by its molar mass. So the mass, of course, is 1 times 10 to the 5 grams of calcium chloride, and we will divide that by its molar mass, which is 110.9 grams per mole. And we get 902 moles. We do the same thing here for sodium sulfate, and we get a different number. Of course, sodium sulfate is slightly larger. It's got a molar mass of 142 grams per mole. So I'm sure you figured out that this will have a smaller number of moles, 704. And because we have less of this, and our ratio between these two reactants is 1 to 1, we know that we need the same number of moles of both reactant in order for the reaction to proceed completely. In this case, we don't have that. So we have less sodium sulfate than we have calcium chloride to fulfill that ratio 1 to 1. So we now know that our sodium sulfate is our limiting reagent. Now we use that information to determine the number of moles of sodium chloride and calcium sulfate by looking at the molar ratios between sodium sulfate and those two products. We see that there's a 1 to 2 ratio here, And shoink, we have a 1-to-1 ratio between sodium sulfate and calcium sulfate. So now we can go through the task of determining the mass of both products. So we sort of work backwards here. We know that the number of moles of sodium chloride will be 704 times 2 because of the we know that for every mole of sodium sulfate we get 2 moles of sodium chloride, so that gives us 1408 moles. We can do the same thing for calcium sulfate. So our number of moles in this case, because it's a 1-to-1 ratio, is 704 moles. So now we need to figure out the mass. In the end, we want to determine what the mass of each of these products is. In order to do that, we need to take this formula that we have here and we need to manipulate it so that mass is equal to number of moles times molar mass. So our molar mass of sodium chloride, we figure that out to be 58.45 grams per mole. And our molar mass of calcium sulfate turns out to be 136 grams per mole. So now we can go and figure out the mass. So we take 1408, multiply it by 58.45, and we get 82,300 grams. Of course, we want to convert that to scientific notation. So that's 8.23 times 10 to the 4 grams. And then let's put it back into kilograms because that's what our starting mass was in. So 82,300 kilograms would be 82.3. Sorry, grams would be 82.3 kilograms. We take, for calcium sulfate, we take our number of moles, 704, multiplied by 136. And we get our answer there to be 95,700 grams. So that'd be 9.57 times 10 to the 4 grams in scientific notation. And that gives us 95.7 kilograms of calcium sulfate. So there you have it. That's a good example of how you can take a double displacement reaction, use it to predict the products, and then determine the amount of products produced in that reaction.